AI can make an experienced engineer far more capable. What happens when engineering students use AI? Listen to this junior engineer carefully.
My generation was among the first engineering student generations to have powerful generative AI readily available. I used it to help with my engineering work during my student years. At the time, it felt incredibly useful. I could get explanations, calculations, code, and even design suggestions almost instantly. But later, during my supervised graduate training, I began to realize something important. Some of the ways I had used AI were actually reducing my learning. Let me show you the 5 dangers I began to recognize. AI changed the way I approached learning. Traditionally, when we faced an engineering problem, we had to think about it, go back to the theory, make an attempt, make mistakes, and eventually work towards a solution. That process could be slow and sometimes frustrating. But I now realize that the process itself was part of the learning. With AI, something very different can happen. I can see a problem, immediately prompt AI, and receive an answer within seconds. The answer can arrive before I have really started thinking about the engineering. And that leads to the first danger. The first danger I began to recognize was getting the answer before I had really thought about the problem. As a student, when I received an engineering problem, it became very easy to make AI my first step. Instead of asking myself, what is actually happening here? What theory applies? What information do I need? I could simply give the problem to AI, and within seconds, I had an answer. The problem was not that AI could solve it. The problem was that the answer could arrive before my own engineering thinking had even begun. If that becomes a habit, we may become very good at obtaining answers without developing the ability to formulate and solve problems ourselves. The second danger is something I did not appreciate as a student. I thought that struggling with a problem meant I was learning inefficiently. Derivations took time. Calculations could be frustrating. Programs failed. Designs did not always work on the first attempt. So when AI could remove some of that difficulty, it seemed like an obvious advantage. But during my graduate training, I began to understand that some of that struggle had a purpose. Working through a derivation helps us understand where an equation comes from. Debugging teaches us how a system behaves. Failed attempts force us to question our assumptions. If AI removes every difficulty, it can also remove some of the experiences through which engineering understanding is developed. The third danger was more subtle. What if I did not know enough engineering to describe the problem properly in the first place? AI can only work with the problem I give it, but an engineering problem may involve requirements, assumptions, constraints, boundary conditions, loads, and physical effects that are not immediately obvious. As a student, I might not even know that some of these things need to be considered. So I could write what seemed like an excellent prompt and still receive an excellent answer to an incomplete or incorrectly described engineering problem. This made me realize something important about using AI. Before I can describe an engineering problem well, I need enough engineering knowledge to understand what the problem actually is. The fourth danger is closely related to the previous one. Even if AI gives me an answer, do I know enough engineering to judge whether that answer is correct? An AI response can look extremely convincing. It may contain equations, calculations, technical explanations, and a very confident recommendation. But somewhere inside, it could be a wrong assumption, an inappropriate equation, an invalid simplification, or a design decision that is unsuitable for the real system. As a student, the answer may even be beyond my current level of understanding. And that creates a serious problem. How can I verify something that I do not yet understand well enough to question? I began to realize that discernment does not come from having access to AI. Discernment comes from developing engineering knowledge and judgment. The fifth danger became the most important one for me. What if I was delegating to AI the very capability I was supposed to be developing? When a lecturer gives us a calculation, a design problem, or a programming task, the purpose is not simply to obtain the final answer. Doing the task is how we develop the capability. The calculation develops analytical ability. The design problem develops engineering judgment. Programming develops our ability to translate ideas into working systems. If AI performs that cognitive work for me, I may still produce an excellent assignment, but the output may improve while my own capability does not. That was the biggest change in how I began to think about AI. As a student, I was not only producing engineering work, I was building the engineer who would one day have to do that work independently. A simple analogy helped me understand this much more clearly. Why don't we give children calculators before they learn basic arithmetic? It is not because calculators are bad. Calculators are extremely useful tools. But first, the child learns addition, subtraction, multiplication, and division. Through doing those calculations, they develop an understanding of numbers and mathematical relationships. Then the calculator extends a capability they already possess. I began to see AI in engineering education in the same way. First, I need to learn the engineering, work through problems, and develop engineering judgment. Then AI can help me work faster, explore more possibilities, and tackle more complex problems. Develop the capability first, then use the tool to amplify it. The real change in my thinking happened during my supervised graduate training. When I faced an engineering problem, my senior engineer often did something I was not expecting. He did not immediately give me the answer. Instead, he asked me questions. Why did you choose this approach? What assumption are you making? Which principle supports this? How would you verify it? Sometimes I already had an answer from AI, but when I had to explain why that answer was correct, I realized that getting the answer and understanding the engineering were two very different things. Gradually, I understood why he kept asking questions instead of simply solving the problem for me. He was not only helping me solve the engineering problem, he was helping me develop the engineer who could solve future problems independently. This experience also changed the way I understood the 4 Ds of using AI: delegation, description, discernment, and diligence. They are useful principles, but for an engineering student, I realized there is something underneath all 4. Engineering knowledge. Can I delegate intelligently if I don't understand the task? Can I describe a problem properly if I don't know which assumptions, constraints, and physical effects matter? Can I discern whether AI is wrong if the answer is beyond my own understanding? And am I really being diligent if AI is performing the very work I was assigned in order to learn? So the 4 Ds are not a substitute for engineering knowledge. They become powerful when they are built on it. So how should an engineering student use AI? I now follow a very different sequence. Think first, attempt the problem, learn from the difficulty, then use AI. I can use AI to explain a concept I am struggling with, challenge my assumptions, review my calculations, find weaknesses in my reasoning, or suggest alternative approaches. But after using it, there are 2 more important steps. Verify the answer, and make sure I understand it. If I cannot explain why the solution works without depending on AI, then there is probably still something I need to learn. So my learning process has become think, attempt, learn, use AI, verify, understand. AI is now part of my learning loop, not a replacement for it. Looking back, I don't think the lesson is that engineering students should avoid AI. AI is an extraordinary engineering tool, and it will almost certainly become part of how most of us work. The important question is when and how we use it while we are still learning. If I use AI to replace the thinking, struggle, judgment, and problem-solving that my education is supposed to develop, I may get better answers without becoming a better engineer. But once I begin developing those capabilities myself, AI can help me go much further. It can help me explore, question, verify, create, and solve problems that would otherwise be much more difficult. So this is the principle I now try to follow. Develop the engineer first, then amplify the engineer with AI. Use AI to extend your engineering capability, not to replace the process that develops it.